Okay, this video is to cover unit goal 5 of our sequence and series unit, and the goal is to be able to recognize and calculate terms of something called a geometric sequence. So in previous videos we talked about sequence and series. We then went on to talk about what an arithmetic sequence was, and what an arithmetic series was basically the sum of the arithmetic sequence. These next couple of videos are going to be about what's called a geometric sequence. So I'll tell you what that is. And then the last two videos will be or next two lessons, I should say, will be on geometric series, which will be adding up these geometric sequences. So what is a geometric sequence? Well, a geometric sequence is a sequence in which each term is obtained by multiplying the preceding term by a number other than 0. The reason we don't use zeros is because if you just multiply everything by 0, you just get a big string of zeros, and that's boring. So basically, we start with a number, and so long as you pick some number other than 0, you just keep multiplying by that number over and over and over again. Now, in the arithmetic sequence, we went up by the same amount, but we were adding or subtracting. A geometric sequence either multiplies or divides. That's the big difference. So notice that these go up by a predictable pattern, but unlike the arithmetic sequence, in the arithmetic sequence, like if this went up by 4, this would go up by 4 to 12, and would go up by 4 to 16, and up by 4 again. Notice these aren't going up by 4s. They're actually doubling every time. So if I actually multiply this by 2, and multiply this by 2, and then multiply this by 2, and then multiply this by 2, that's the pattern. So in a geometric sequence, each member, you can get the next member by multiplying the previous member by some number. So in this case, I'm multiplying by 2s. The number doesn't have to be a whole number, nor does it even have to be positive. This is a geometric sequence. The multiple is -3. So if I take 1, I can multiply by -3, get -3. Multiply again by -3, I get +9. Multiply again by -3, I get -27. Multiply again by -3, I get +81. And so on. I multiply by -3 again, I could do that forever. The numbers can also be fractional, because notice here I'm not really multiplying by a whole number. I'm multiplying by a fraction. So these are actually dividing by 2. I'm dividing 2, dividing 2, dividing 2. But if we put it in terms of multiplication, hopefully we realize by multiplying by the reciprocal that dividing by 2 is the same as multiplying by half. So instead of saying I divide by 2, I could just say I multiply this by half, multiply this by half, multiply this by half, multiply this by half, and I could keep going. Notice that my sequence can generate decimals and weird numbers. So a lot of times we like when the sequences have whole numbers in them or positive numbers, but they can have negative numbers. They can also have fractions, okay? So each one of these is an example of a geometric sequence. So along with what we've done before, there are some patterns and some formulas we can come up with. So let's first talk about finding this special number. The special number that I've been talking about is referred to as the common ratio. So when we did the arithmetic sequence, it had something called the common difference. Because now we're multiplying, they call the number that we multiply by the common ratio. So the common ratio is the number I need to multiply one term to get the next. So before I talk about that formula, the common ratio here is 2, the common ratio here is -3, and the common ratio here was 1/2. Basically, it's what you have to multiply by to get that next term. There are two formulas to find it. I'm going to go over them before I do the problem. So the simple formula is, the reason it's called the common ratio is because if you divide the term after by, I should say this is the original term, and then this would be the term after. That's what the n+1 is. So basically, if you take some term and then divide by the term before it, you should be able to find the common ratio. So that's how you're reading this. It's a little funky in the notation, but basically the common ratio can be found by taking some term and taking the term after it. And if you divide the term after it by that original term, you'll get it. So illustrating on this example, so long as I take a term and the term before it, so like if I took 16 and divided it by 8, that ratio, 16 over 8, is 2. I could take 64 and divide by 32. I'd still get 2. So notice that so long as I pick two that are next to each other and divide one by the other, the later one divide the sooner one, I'll be able to get the common ratio. And that works anywhere. If I took negative 27 divide 9, I'd get negative 3, which is the common ratio. Or if I took 3 divide 6, 3 divide 6 is a half. 0.75 divide 1.5, that's a little weird to do in your head, but that also comes out as 0.5. So, so long as you take some term and divide by the one before, you can get the common ratio. Now, that's the simpler version of the formula. We run into the issue like we did last time is what if the terms aren't next to each other? So say I wanted to find the common ratio, but the two terms weren't back to back. So unfortunately, I can't just take this and divide this because 64 divide 8 would give me 8. But the problem is it needs to get from 8 to 64, but I need to do it over 3 terms. So I'm going to share a more general formula with you. And here's how you come up with it, just so you kind of have an idea of where this, because formula looks a little weird, but hopefully this will show you why it is the way it is. These x's are just representing the unknown term. So there's term 1, term 2, term 3. Here's term 4, which is 8. And then I don't know 5, I don't know 6, but I do know term 7. So then how do I figure out what the common ratio is? Well, the common ratio by definition would be, well, if I multiplied by that common ratio, I'd get this number. And then do it again, I'd get this number. Then do it the third time, and I would get this number. I could set up an equation with that. Basically, this equation, if I do 8 times r times r times r, if I multiply by r 3 times, that's like cubing it. So basically, if I take 8 times r times r times r, I should get 64. Now, if I solve this, I actually get the structure of the formula. So what will the formula look like? Well, I'm going to take this term and divide it over. So notice that I do divide the two terms, but I'm not done. I can do 64 divide 8. The problem is there's that gap of 3. There was 3 steps I had to make. That's represented by this exponent. So how do I get rid of the exponent? I actually have to take a radical. I have to do the cube root to both sides. So this actually gives me the structure of the formula. How do I handle the fact they're not next to each other? I still divide the two terms like in the last formula. The last formula said divide the two terms. But now instead of dividing the two terms and just getting an answer, I divide the two terms and I take the root. Where did this root come from? Well, notice that it's 3 steps. I can get that by doing 7 minus 4. So this number is 7 minus 4, and I took the 7th term divided by the 4th term. All of this you could stick into a calculator, or if you're good with calculations, you might be able to do this in your head, because this comes out as cube root of 8, and cube root of 8 is 2. So the common ratio here is 2. This value is 2, and I can prove it because I can just go, well, let's see if it works. 8 times 2 is 16. 16 times 2 is 32, and 32 times 2 is 64. So that's the number I was looking for. So what's a formula so I don't have to do this every time? The formula looks weird, but hopefully now it'll at least make a little bit of sense. So what's the general common ratio formula? Say the two terms are not next to each other. That's what the n and the m mean. So this could be any term and any other term. How do I find their common ratio? Well, I'm actually going to divide the two terms, but because they may not be next to each other, this is how I handle the fact they're not next to each other. Wherever these two little numbers are, you put them in the index of the radical. So to talk through this calculation, how would I make it without doing all this? Well, I knew a sub 7 and I knew a sub 3. And I put the 7 minus 3, or sorry, a sub 7 and a sub 4, sorry. This is a sub 7, this is a sub 4. I'd put 7 minus 4. So now 7 minus 4 would give me the 3. And a sub 7 was that number, and a sub 4 was that number. So basically, if I plugged in the 7 and the 4 into these spots, I'd get this, and then replace those, and I'd get this expression, and then I could calculate it, all right? So this is how you can find the common ratio if the terms are next to each other, is the first formula, and this one finds it if they're not next to each other. The only difference is when they're next to each other, you divide them. If they're not next to each other, you still divide them, but then you have to put this radical on where you take their list numbers and subtract them, all right? So this one will be in the last example, so keep in mind both these things. as now we talk about, now we want a formula to find the nth term. So here, I try not to go too high. Say we're going to find the 7th term. Now, one way to find the 7th term is I could just, once I find the common ratio, just do it by hand, right? Start counting up till I get to 7. But I want to go through a shortcut formula because, once again, on the homework, I could make this a sub 50, and you wouldn't want to have to go through and do 50 terms. So the first step is to find the common ratio. I can use the first formula in this case to find the common ratio because I have the terms next to each other. I can just do this, divide this, negative 12 divide 4 is negative 3. So once I have the common ratio, now if I were to do it by hand, I would have to multiply by negative 3, negative 3, negative 3, and I have to keep going. I'd have to do it one more time for 5, another time for 6, and one last time for 7. So I could do it by hand. But I want to talk about the formula. Just like we have formula for the arithmetic sequence, it's very similar to the formula for the geometric sequence. Basically, if I want any term, like say I want the second term, I have to take the 4 and multiply by this one time. Say I want this term, I have to take the 4 and multiply this 2 times. When I multiply something by itself 2 times, I square it. So basically I have to take this number, and to get the third term, I have to take this number and take this number and multiply this by the power of 2. Say I want to get to this number. Well, I'd have to take 4 and have to multiply by this number 1, 2, 3 times. So I would have to actually do 4 times this to the power 3. Now this creates a pattern. If I wanted this term, the 5th one, I would have to multiply this 4 times. So I have to multiply it by itself 4 times, which is raise it to the power 4. So if I want the 5th term, I can do this times this number to the 4th. If I want the 6th term, this times this number, what did I say? Let me say that again. If I want the 6th term, I'd have to do this times this to the power 5. If I want the 7th term, I would do this times this to the power 6. So basically there's this pattern that I can always take the first number and then multiply it times this to the power of 1 less than what I want. And if you remember that n minus 1 was also in the formula for the arithmetic sequence. So let me show you the formula, and then I'll show you in the calculator how to get it, and then do a better example. Say you want the nth term of a geometric sequence. So if I want term a sub n, I can basically take the first term and multiply it by this thing. What is this thing? It's the common difference to the power of 1 less than the number I'm looking for. So that's the pattern I was trying to talk about on the other screen. So like if I want the 7th term, I need to put in 7 minus 1, which is 6. So let me show this in the calculator. Say I want the 7th term, and I don't want to have to do it by hand. Basically, I need the first term, which is 4, the common ratio, which is negative 3. So this is going to be 4. This is going to be negative 3. And then I'm just going to do 7 minus 1 and get 6. So what is that term? I'm going to throw in the calculator here. So I'm going to take the first term, which is 4. I'm then going to multiply it by the common ratio, which was negative 3. Now, when I show you the calculator, I'm going to put that in parentheses. I'm going to put it to the power 6. So what was the 7th term? It's the first term times the common ratio to the power of 7 minus 1, which is 6. So in the calculator, I have entered 4. Now, be careful with the parentheses. I'm putting that negative 3 is being raised to the power, so that negative has to go into the parentheses. If you forget that, you can get screwy answers. So it's important you remember, especially if it's negative, to throw that into the parentheses. All right, so what is my 7th term? It's the first term times the common ratio to the 7 minus 1 power. So that's what I've entered, that formula. All right, so what is it? It is 2,916. So that is how my value is supposed to come out. All right. So just to show that, so now that I've talked through it, it's probably better just to look at it. So how do we find a sub 7? Here's what I did. So here's my sequence. I want the 7th term. I'm going to take a sub 1, r to the n minus 1. That's the general formula. I threw in the first term, 4. I threw in the common ratio, -3. I threw the 7 in there. That gives me -3 to the 6, which was 729. And then times 4 was 2916. So notice that's exactly what I put in here. All right, so that's talking through it. There's seeing the work. So now that you've seen it, see if you can figure out the 10th term for this. Try using the formula. Just to give you a hint, the common ratio is a fraction, because notice these are dropping. So divide them to find the common ratio. Once you know the common ratio, you have the first term. See if you can use that formula. As you're more than well aware, we're on a video, so you can pause the video and figure that out. I'm just going to go ahead and show you the answer. So what is the 10th term? Well, here's that sequence. I need the common ratio. In this case, you can use the simpler formula of just dividing the two terms. So term 2 divide term 1, 2048 over 4096. That simplifies to 1/2. You can throw that in a calculator, or you might recognize, okay, well, those are getting cut in half. So that's my common ratio. Now using the formula, well, I want a sub 10, so I need to take the first term times the common ratio to the power of 10 minus 1. So that's 4096 times 1/2 to the 9th, and that comes out as 8. So I could take the time of cutting these in half over and over again, or I could just go, well, what's that 10th term? This thing just gets it for me. I don't have to go ahead and make 10 numbers up there, all right? So it comes out as 8. Let's look at one last example. So just like with the arithmetic sequence, sometimes they don't give you all the information you need. To use the formula would help if I had the first term and the common ratio in order to find this. But I don't have the first term or the common ratio. That's why they're asking me to find it. So I'm going to show you how to find them and then how to answer the actual question. So basically they want to know what a sub 12 is. It's a little hard to find because I want to find a sub 12, but they gave me the 3rd and the 7th term. All right. So since I have the 3rd and the 7th term, the terms aren't next to each other. I'm going to have to use that formula I showed you earlier with the radical to find what the common ratio is. So the structure of how I'm going to solve this is, my end goal is to find a sub 12. In order to use the formula, I really need these two things. And to find these two things, these will help me. So I'm going to start by using these two things to get the common ratio. Once I have the common ratio, I'll show you how to use them and the stuff you know to get a sub 1. And once you know these two things, this is then easy to find with what we just did. All right, so if I want to answer this fully, I'm going to show the work on the board behind. All right, so I have it in the steps I just mentioned. So it's going to go from the left over to the right. So given these two pieces of information, I'm going to show you how to find the first term, the common ratio, and the 12th term. And I'm starting with the common ratio. I don't know why that's there. So probably supposed to be a comma. Starting with the common ratio, I can use that formula. Now the terms are not next to each other, so I need to know what the n and the m is. I'm going to pick the n to be the bigger one, the m to be the smaller one. That way this doesn't come out negative. So I'm going to plug in a sub 7 and a sub 3, which means the numbers in here are going to be 7 minus 3. 7 minus 3 is 4, so I need to take a 4th root. I need to take a 4th root of what? Well, I need to take a 4th root of 320, which is that number, divide 20. Now, if you don't know how to calculate this, you can get it out of the calculator itself. If you go to math, So I just hit the math button. You'll see selection 5 is the xth root. So you can do any root you want. If I want to do a fourth root, after I hit that, see the blinking light up there? Well, I'm going to put in the 4 and then put in that fraction, 320 divide 20. Now, you can use the fraction button. I just decided to divide it, and if I hit enter, notice it calculates that for me. So if you're good at calculating, you might not need this because doing it in my head, 320 divide 20 would be 16, and I know the fourth root of 16 is 2, but if you're not that up on everything, the calculator gives you the solution. All right, so just remember to go into math, and it'll do any root you want. So now I know the common ratio, too. That's part of what I needed. I also need the first term. So just like in the previous video with the arithmetic sequence, I had mentioned, well, if you use the formula, you can always find the first term because you can put in a term you already know. So I put here, pick a term you already know. You can pick either the third or the seventh. I'm just going with the third because it's a little smaller. So if I want to get the first term, I'm going to use the fact I know the third term. So plugging it into this formula, if I plug in the third term, which I know, I'm going to leave the first term blank because I don't know what it is, but now I know the rest of the information. The common ratio is 2, so I'm going to plug that in. And since I know that I'm going to use the third term, I know what n is. N is going to be 3, so I'm going to use 3 minus 1. So now, what is the third term? It's 20. A sub 1 I don't know, but I know that 2 to the power 2 gives me 4. So I get 20 equals 4 times a sub 1. Divide the 4 on both sides, so divide this 4 over, and you get a sub 1 equals 5. So now I have the common ratio and the first term. With the common ratio and the first term, I can now go and answer their question, because that's what I needed. What is a sub 12? Well, a sub 12 is, according to this formula right here, a sub 12 is the first term times the common ratio to the 12 minus 1. Well, I now know the first term, it's 5. I knew the common ratio from before, it was 2, and 12 minus 1 is 11. So what's 5 times 2 to the 11th power? Well, 2 to the 11th power is pretty big, times 5 makes it even larger. It comes out 10,240. Now, it's not uncommon in these geometric problems, keep in mind, that the answers can sometimes come out kind of weird. It's not uncommon to get very big answers, or if the common ratio is a fraction, because here it came out as 2. If the common ratio was like a half, if you keep cutting things in half over and over again, they can get very small. If you double things over and over again, they can get really big. So when you do these problems, you may run into answers sometimes that are extremely large or very, very tiny decimals. So if you get those, don't be discouraged. If you follow the formulas, the answer should be correct. All right. So hopefully so just to recap real fast, this showed how to do geometric sequence formulas, basically how you can get the nth term of a geometric sequence from the first term in common ratio, and then how do you get the common ratio? There were 2 formulas for that were from earlier on in the video. So basically this is what you'll need to know about geometric sequences. The next 2 videos will talk about how do we add up these geometric sequences. There will be a geometric series formula, but that's for the next lesson. All right, so check out the assignment that's with this and see if you can use these formulas to figure those out. All right, and you got any questions, you know how to contact me. All right, have a good one till next time.